Welcome to The Elements, a visual exploration of every known atom in the universe. Today we are starting off our journey with palladium. Now, if you've ever heard of gold sleeve, gossamer, thin sheets of gold used to, you've probably seen of them. If you haven't ever heard of gold leaves, you've probably seen them a lot, and they've been used since antiquity to like cover or gild objects. Palladium too can also be done that. It can also be beaten into sheets nearly as microscopically thin as gold leaves, and then you can go ahead and apply them onto things, which makes them shiny and look a lot like palladium. It has been used in that form to imitate silver, which is kind of ironic because it costs about 20 times as much silver. And some unused, some solid palladium is used as jewelry, but as with rhodium, its main application is for automobile catalytic converters, and these devices are really useful too. Once the waste comes out, it just reverts into the carbon dioxide and water, which is really useful because now you can burn stuff without a flame. The great thing about palladium is you can do that at very low temperatures, meaning there's lower risk of your car or motorcycle burning up. So in the end, this is pretty much how palladium works. It has an atomic weight of 106.42, it has a density of 12.023, it has an atomic radius of 169 picometers, its crystal structure, it's a cube, and it has a pretty low melting point, and it finally filled up the 4Ds. Next we have silver. Silver, really expensive. We have been using it and we have loved it since the olden ages. The main problem with silver though is that it tarnishes, which seems like an immediate disqualification for this kind of metal of kings, but despite this shortcoming, it is pretty rare as well too. Rare enough so that it is the metal of kings. It's the first element that we've encountered that has been associated with antiquity and glory and riches. I guess if you can afford a staff of silver polishers, well, you probably won't need to mind about all this silver polishing. While silver and gold go hand in hand, silver is definitely the junior, mainly because, well, historically it has been sold for about a 20th the pound of gold, and the last century the ratio has been as much as 1 to 100. And gold itself is not the best at any one thing. It's not the most corrosion resistant. It's not the most hardest. It's not the most valuable. It's not the most anything. But silver can at least claim 2 prizes at most. Of all the elements, it is the best electrical conductor, and it also the most reflective one. I guess that is what made silver very attractive. Gold zone, we just decided one day that it is very attractive. And for mirrors that need to be as reflective as possible, well then, you can look no further than silver. It has by itself an atomic weight of 107.8682, its density is 10.490, its atomic radius is 165 picometers, and the crystal structure, it's a cube. Along with, well, finally we just skip ahead to the 5 S's. And so next up, we're going to go ahead and talk about cadmium. Cadmium is perhaps the best known. Its use is the nickel-cadmium batteries. Nickel-cadmium batteries are itself pretty well off. So these days they are maybe replaced by all those nickel metal hydride and lithium-ion batteries nowadays. So cadmium by itself, so it does have its own advantages and several ones as well too. Cadmium, unfortunately, is a lot like lead and mercury, and that it accumulates both in the environment and in the body, which causes long-term damage, and we don't want long-term damage, do we? Mercury will able to go ahead and accumulate in people, but, well, we don't want any of those metals doing here. That's why NiCad batteries should be taken to stores or collection points that recycle them, in my opinion, so, and including the offers 15 and 2. You shouldn't throw away cadmium. Just like lithium-ion batteries, you should go ahead and go to them in the stores and get some reward points for, like, giving them back. However, mostly they are used in several different applications. You can use them for gallium foil, intended for radiation shielding, and you can even use them in some brake rotors. Oh yeah, and sometimes treatment with diachrite can give cadmium-plated nuts a gold color. It has an atomic weight of 112.411, it has a density of 8.650, its atomic radius is 161 picometers, its crystal structure is a hexagon, and it has a really low melting point, and a really low boiling point as well too. It filled up the 5 S's. Next up we have indium. Indium is not named after India or Indiana or any other kind of place. In fact, it's named after the strong indigo blue that is used to create for it. In fact, lots of badges use indium inside their indigo colors, and so that kind of makes sense. Lots and lots of LCD screens need all that. In the application that it is in the form of indium tin oxide, a transparent conductor of electricity that allows the signals to be communicated to the individual pixels in a display without blocking it inside LCD screens. No matter what, you have to use indium. The pure element itself is also a good conductor, but not really transparent by itself. Being a soft, silvery, and quite fun metal, in pure form it's so soft you can really easily just well, shave off a few slices with your pocket knife, and so far as we know, it's not that durable. And since it is one of the few substances that wet glass instead of being repelled by the stuff, it can be used as a gasket material in like high vacuum application places. It has an atomic weight of 114.818, its density is 7.310, its atomic radius is 156 picometers, and it has a crystal structure of a cuboid. And next up we have tin. This is a tin soldier back in the day when they were still made out of tin instead of plastic. Tin is a very lovely metal element if it wasn't just so if it was not so something. It's very non-toxic and it stays shiny, like shiny forever. It's easy to build and cut into minute detailed shapes, and well, not horribly expensive. I mean, really, what could you ever ask for? Back in the day when we created tin soldiers out of lead, that was terrible. Now we created out of tin, and then later we went ahead and did that. And then tin lead alloys were a frequent choice, and in those days all toy soldiers were not made of plastic. Today, the idea of using lead, well, lead inside this is not really good. It's like making a balloon out of lead, and you know how well that goes. If you visit a scrap metal yard, so anything that you think of as a foil that's made of a metal, they'll probably just call it tin, even though it's made of aluminum or something else. There are several coins that are minted with tin, but there is an odd property with this. At wintry temperatures, tin starts to convert very slowly over a course of months, from a very silvery metal into a dark gray powder. So you have to keep tin really, really safe in good room temperatures. It has an atomic weight of 118.710, its density is 7.310, its atomic weight is 145 picometers, and it has a crystal structure of a cuboid. And in the end, it really does have a really low melting point, as I mentioned earlier. And that's pretty much it. And it's starting to go into the 5 Ps, and it has skipped entirely the 4 Fs. And that's about it. That's all I have for tin. I hope you guys enjoyed this episode. Hope to see you guys soon. Until next time, Sean out. Peace. Bye bye.